Hello, and welcome to Physics 2212, Lab 2, Lines of Charge by Blake Schwabe. The purpose and description of this lab is using charge tape and computer models. We're going to be showing the exerted electric force from one piece of charge tape to another across the whole piece of charge tape by basically splitting them into n number of sections and not just one piece in the middle of the tape like we did in the first lab. Preview the results, the point charge. So from the first lab, it would be 1.26 times 10 to the power negative 8 C, while the charge of the whole tape is around 3.984 times 10 to the power negative 9 C. Some important concepts, formulas, and assumptions. Newton's second law and gravitational force being connected together. Coulomb's law using those forces connecting together to actually find charges. Law of superposition basically being able to let us add each individual force from a point charge all together to make one long kind of strain of multiple different sections across the entire tape and not just in one certain section. The assumptions we're going to have, we're going to ignore air resistance on the moving object, so the tape. We're going to treat the tape kind of like a point charge, each section of it, and basically at the center of that. And we're going to be assuming each U-tape that we made has about the same amount of charge evenly distributed along the length of tape. Now, values I got from lab 1 and the system settings. So we got the tape length of about 0.2 meters, tape's mass about 0.2 grams. The distance between the tapes is around 2.7 centimeters. The tape's width being around 0.0127 meters, gravity being negative 9.81 meters per second squared, gravitational force being negative 0.00196 newtons, charge of the tape being 1.26 times 10 to the power negative 8 C, the system itself being tape B, and the surroundings being everything else besides tape B. Calculations. Why we're using specifically rod is because we've sectioned them off into multiple different n number of sections on this tape, and basically it becomes a rod of charges from tape B to tape A. So we're trying to find Q, the actual charge. So we need the force of the rod, and then we need R, which is just the distance, K being a constant, and then L being the length of the tape itself. And then when you plug all that into the formula given up here, you are given 3.98446985 times 10 to the power of negative 9 C for our estimate. Here's the coding for part 1. We have our mass, the net charge, the length, the distance between the tapes. We have the calculations for the electric field. We have the function for the line charge all here. And then for part 2, we have the top and bottom tape, the line charges for those. Scales for everything here. And then this is the for loop that utilizes to each singular piece and basically calculating all of them and then adding them together to kind of make something like this. So the magnitude of the electrical force is about 4.5 times 10 to the negative 9. That's the magnitude of gravitational force would be 1.96 times 10 to the power negative 3. Now, understand this. This is not perfectly correct because there were some human errors done probably throughout, and it should be a lot closer in a perfect system throughout everything. Some sources of error would be rounding, probably the most common one. Off on measurements because you can't get as precise as you want. Tampering with the tape, I could have accidentally touched it. An item could have accidentally touched it. And things like that. The air itself could have interacted with it and it would have messed it up. Human errors within the code or making the calculations. Sometimes small little errors slip up. Air resistance, didn't account for it, but it could have happened. Setting not being perfect, it could have been water vapor or something like that in the kind of air itself. And the charge of the tape could have not been evenly distributed, even though we assumed so. So what if and why? So what if the model of each of your tapes was a single point charge like in the previous lab? If we compare them, Lab 1's charge is bigger than Lab 2's charges by a great margin. But why do these estimates differ? Well, it's because we have two different systems. One's a concentration and one's having them evenly spread out. If you want to know which one is truly closer, then Lab 2, because the charges evenly spread across from it more likely than in one single concentration point, like in Lab 1. Thank you all for watching. Hope you enjoyed.